Okay, this is MAT 175, Lesson 26, Section 8.1, Right Triangle Trigonometry, Applications. Well, before we get to the applications, we're going to do some basic problems in trigonometry, right triangle trigonometry. At that, find the value of the trigonometric function of acute angles using right triangles. Okay, so this is basically how the right triangle fits into the unit circle, where you have your x values and you have your y values here. Your hypotenuse we're looking at as C, and so how we apply that sides A and B, square of side A and square of side B equals to the hypotenuse of square of side C. And so we will use, as long as you have a right triangle where you have one side perpendicular to another side, then you can use the Pythagorean theorem. If you don't have a right triangle, then you cannot use the Pythagorean theorem. You have to use something else. But in this case, we're working with just right triangles, so we can use the Pythagorean theorem in these problems. And we had mentioned before that there was a memory device that we used, and we call that SOHCAHTOA. And that would be sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. And so therefore its reciprocal trigonometric functions, cosecant, since sine is opposite over hypotenuse, cosecant is going to be hypotenuse over the opposite side. Cosine, since that's adjacent over hypotenuse, secant, its reciprocal identity is going to be hypotenuse over adjacent. And cotangent, since that's the reciprocal function for tangent, that's going to be adjacent over opposite. Okay, here we're going to find the values of each of the 6 trigonometric functions of the angle. And first thing we have to do is to find the opposites. We want to find the side that's opposite theta. 3 is the adjacent side to theta, 5 is the hypotenuse to theta. So we need to use the Pythagorean theorem here. Now, I always recommend the students to start with the hypotenuse, because the other two really don't matter, but the hypotenuse, you got to get that right. So this is always going to be, if you look at this in terms of c squared equals to a squared plus b squared, or you could say b squared plus a squared, or a squared plus b squared. That really doesn't matter which one's a or b. But the hypotenuse does matter. So the hypotenuse is 5. So there'll be 5 squared equals to the opposite side squared plus 3 squared. And so we get 25. 5 squared is 25. 3 squared is 9. So there'll be 25 minus 9 is 16. Well, at this point, we have to apply the square root, and since there's no such thing as a negative length, we just drop the plus or minus, and just our answers for the right triangles are always going to be a positive, because we always have a positive length. We never have a negative length. So our answer here for the opposite side is 4. We have our opposite side is 4. And so from there, we can find our 6 trigonometric functions. And so sine is going to be opposite over hypotenuse. So since this is 4, then that would be 4 over 5. And so since sine is 4 over 5, cosecant is going to be 5 over 4. And cosine is adjacent over hypotenuse, that's 3 over 5, so secant is going to be 5 over 3. And tangent is opposite over adjacent, so that's going to be 4 over 3, and so cotangent is going to be 3 over 4. And so we have our 6 trigonometric functions and our values for those. Okay. And so let's take a look, and we want to solve for right triangles. And so with this, we can say that we have a Pythagorean theorem to find the third side of a right triangle. But to find the third angle of a right triangle, we know that all 3 angles add up to 180 degrees. Well, if we look at this, we know that angle A plus angle B plus angle, in this case C, would be 90, and all 3 angles inside a right triangle have to add up to 180 degrees. Well, if we subtract 90 from both sides, then we get A plus angle B equals 290 degrees, and so we can just use that in solving for our right triangle. And when we talk about solving our right triangle, we're talking about finding all the sides and all the angles from where we are given. So to start with, right away we can find that if angle A is 40 degrees, and we don't know what angle B is, if we subtract 40 from both sides, we get angle B equals to 50 degrees. So we know this is 50 degrees, and we're given that side B is 2, a value of 2. Now, when you're given sides and angles, if angle B is 50, then the side opposite is going to be side B. If here we have angle A, and so the side opposite angle A is side A. And then we could say that the right angle is angle C, so the side opposite angle C is going to be side C. So that's how we know our relationship between our sides and our angles. Okay, so far we know that we have side B is 2 and angle A is 40, and we already found angle B is 50, and we know angle C, since we have this perpendicular symbol here, we know that's automatically going to be 90 degrees. So we need to find the other 3 sides. So with that, we can say, alright, we have here angle A and we have angle B, and we can say that we have here 50 degrees. We know we have 50 degrees there. So we have one side, 2. And so let's say that we want to find side A. So we can say tangent of 50 degrees. Well, we know that tangent is opposite over adjacent. So the opposite side is 2. Adjacent side we don't know, so we'll just call that A. And so now what we do at this point is we have to get that A out of there because we're solving for that. So we multiply both sides times a, and we get a tangent of 50 degrees equals to 2. And now we're going to divide tangent 50 degrees to both sides, and we get a equals to, now in the calculator, again, since we're working with degrees, our mode has to be in degrees. So I would recommend that you check that every time, because you're going to be switching back and forth between degrees and radians. Okay, so this will be 2 divided by tangent, and that's going to be 50 degrees. And we hit enter, and we get 1.678. So we're going to round that to 1.68. 1.68. So side A is 1.68. And so now, at this point, we can use the Pythagorean theorem to find side C. And we can say C squared. Now at this point, we can store that value into X and use that. So we're going to store that into X and hit enter. So this is going to be C squared equals to A squared plus B squared. And so we don't know what C is, right? So this will be C squared equals to A. We know that's 1.68 parentheses squared. We have that stored in X. Plus B is 2 squared. Okay, so that's going to be C squared equals 2. So we put in here, and we could just use answer, right? So that's going to be X squared plus 4. 2 squared is 4, right? So I just put 4 in there. And we get 6.816, and it goes on. 6.1 or 6.816, it goes on. So we are going to apply the square root, but we don't have a negative length, so we just drop the plus or minus. And so we take our answer, apply second, and a radical, and we're going to hit second and answer, and we get 2.6108, so that'll just be 2.61 for side C. And so we, at this point, we get 1.68 and 2.61. So they did it a little bit differently. They used tangent cosine for both, but you could, we found tangent of 40 degrees is well, we did 50. Now notice they did tangent of 40. Tangent of 40 would be opposite over adjacent. We didn't know what this was. This was A. So this is opposite over adjacent, and they found that they got 1.68. So what they did is they multiplied 2 to both sides, and they got 1.68. And you could also use cosine of 2 over C to get 1.68. Cosine of 40 degrees would be 2 over side C, and they get 2.61. Now we used 50 degrees, and we did opposite over adjacent, found side A, and then from there we used the Pythagorean theorem. So you can see that there's more than one way to solve these problems, and we still got the same answers as this slide. Okay, here we have, now at this point I want to explain something. Here we know in the past that, let's say we have here f of x equals 2x squared, and we have f of inverse equals to the square root of x. So if we were to cut this x out here and here, and we have inverse, and we have parentheses. And we put in here square root. And we have parentheses here where the x was. And now we want to find the inverse of f of x. F of inverse of f of x. So that means the x squared is going to go where the x was, because we cut that out and put x squared in there. Well, these two are inverses of each other, and we get just x. Well, if we have here the inverse sine of sine of x, these two are inverses of each other, and you just get x. They're f of inverse and f of x. So if we have here, let's say sine A equals 2b. And now what we're going to do here is, I'm going to rewrite this down here. Sine A equals 2b. And so now we apply the inverse sine to both sides, and since the inverse and sine are inverses of each other, all that's left is just the angle. Well, equals to inverse sine b. And we do this when we don't know what the angle is, but we do know what the value is. We have a known value, but an unknown angle. So we don't know the angle, but we do know the value. So we can apply the inverse sine to both sides. Again, because we want our answer in degrees, you have to make sure your mode is in degrees. Okay, with that, let's take a look at our problem. Alright, here we have, here's angle A, so this would be side A. Here. So we're saying side A is 3, and C, that's opposite of angle A. Side B is opposite angle B, and that's 2. Well, this would be angle C here, but and that side opposite that would be side C. Alright, so knowing that we have our values in here, but notice we don't have any angles, so we can't find our angles yet, but we can find our third side. And how do you think we're going to do that? You should have said that we're going to use the Pythagorean theorem, because we have a right triangle. So we go ahead and apply, again, the hypotenuse. That'll be our C. We don't know what that is, but we do know. And it doesn't matter if you put the 3 squared first or the 2 squared first, that doesn't matter. And so basically what we had here was C squared equals 2 squared plus 3 squared. And so we applied square root to both sides, and that's what we got to here. Well, 2 squared is 4, 3 squared is 9, so that's going to be the square root of 13. Alright? And so we get 3.61. And I would even put here, I would just leave it square root of 13 for right now, and work with that until you're finished. Okay. And so we have that. We get approximately equal to 3.61 rounded off. Now we can go ahead and find our other two angles. And so at this point, some people like to start with, finding the inverse of the angle that's, the bottom angle. So with that, we're going to have here sine of angle B. And And actually, since I always like to work with the values that are not rounded off, so we could, if you're going to use sine of angle B, I would use square root of 13. I would not use the rounded off value. And so we're going to use the square root of 13. So sine is going to be 2 over the square root of 13. And so that'll be 2 over the square root of 13. Now, because this is not going to be a final answer, we don't have to rationalize this square root of 13 in the denominator. Just leave it the way it is. Alright, and so now we are going to, because we don't know what angle B is, right, what do you think we have to do at this point? You should have said that we are going to apply inverse sine both sides. Apply inverse sine both sides here. And so we get B equals to, and then on the calculator, so you're going to have here inverse sine of 2 over square root of 13, and then we go ahead and put that in our calculator. And since we want our angle in degrees, we want our mode to be in degrees. Okay, so this will be second and inverse sine. And we're going to put in here 2 over the square root of 13. Close the parentheses. And we are checking, and you want to make sure that you're using inverse sine here, not just regular sine. And we get 33.69006753, and so this will be B is approximately equal to 33.69 degrees. Now, depending on what they want you to round it to, is going to depend on what your answer is going to be, of course. So we can say that this is 33.69. Well, how do you think we're going to find angle A? You should have said that we're going to subtract the 33.69 from 90. So this would be 90 minus 33.69. And so now I'm just going to put in here 90 minus, and then second and answer. And we get 56.309. So this will be 56.31 degrees. And now we've got all our sides, and we've got all our angles, and we've solved our right triangle. Well, you're going to see here that we're going to get the same values. Now, they may have done it differently. They used tangent. We used sine. But we used the square root of 13 and not 3.61. And there's different ways you could do it. You could have done the you could have used cosine. Here they use tangent. So here they applied tangent is opposite over adjacent. 3 over the tangent A. So here they use tangent A, which is opposite over adjacent. 3 over 2. Or you could have used tangent of angle B, and that would have been tangent of angle B is 2 over 3. You could have done that too. And then they applied inverse tangent to both sides, and they just rounded it to the nearest tenth. And then they went ahead and subtracted 56.3 from 90, and they got their third angle, which is 33.7. And we got we used 33.69. They put round up to 33.7. And we used 56.31. They just rounded to 56.3. So the methods were different, but the answers were the same. So there's many different ways that you could solve the same triangle.